Deep beneath the Pacific Northwest's forests, a secret has been hiding. For centuries, Mount Rainier, Mount St. Helens, and Mount Hood stood as silent sentinels. Thanks to USGS satellites, we now know these volcanoes are linked by hidden underground pathways. The data revealed a network of magma tunnels connecting the giants. The quiet giants are now seen as connected siblings, sharing a single, fiery heart. The era of seeing these volcanoes as isolated threats is over. What are magma tunnels? Think of them as the Earth's secret plumbing. Deep underground molten rock, magma moves through long tube-like conduits connecting volcanoes like arteries. These tunnels aren't empty, they're dynamic, with magma flowing at different speeds and pressures. Over time they can widen, branch, or even create new roots. Imagine a tree's roots, but instead of water, they draw molten rock from deep within the planet. This network can stretch for miles, linking volcanoes far apart on the surface. Finding these tunnels is a triumph of modern science. Scientists use satellites to detect tiny changes in gravity and ground elevation, clues that reveal the hidden architecture below. A tunnel filled with less dense magma creates a weaker gravitational pull detectable from space. INSAR radar tracks millimeter-sized changes in ground height as magma moves. By combining these clues, scientists map the secret world beneath our feet. The discovery of these tunnels is a game changer. It shows the volcanoes share a source, or at least a way for magma to travel between them. This means the volcanoes are not independent. They're part of a larger regional network. Pressure in one part of the system can affect another, just like faucets connected to the same water main. The consequences of this connection are dramatic and far-reaching. To grasp the scale of this discovery, consider the volcanoes themselves. Mount Rainier towers over Washington, its ice-covered peak a symbol of both beauty and danger. Rainier's glaciers pose a unique threat. An eruption could unleash catastrophic mudflows or lahars, burying communities. Mount St. Helens, infamous for its 1980 eruption, demonstrated the explosive power of the Cascades, flattening forests and blanketing the region in ash. Since then, St. Helens has remained active, a constant reminder of the magma below. Mount Hood, Oregon's highest peak, is a popular destination but far from dormant. Swarms of small earthquakes and ground deformation signal magma movement beneath Hood. Like Rainier, Hood's glaciers could fuel devastating lahars in an eruption. These three volcanoes are part of a chain stretching from California to British Columbia, formed by the subduction of the Juan de Fuca plate. For decades we studied them as individuals, each with its own history. The discovery of magma tunnels forces us to see them as a connected system. They're not just neighbors, they're physically linked by a shared fiery underworld. This new context changes how we assess risk and prepare for the future. The threat is no longer isolated, it's regional and interconnected. Understanding this connection is crucial for everyone living in their shadow. The tunnels form a vast, Y-shaped network beneath the Cascades. The main trunk draws magma from deep beneath central Oregon, then branches north toward Mount Hood. From Hood, the channel continues to Mount St. Helens, explaining its frequent explosive activity. The most surprising link is a secondary tunnel stretching from St. Helens to Mount Rainier. Rainier, less frequently active, may be at the end of the line, receiving magma more sporadically, allowing pressure to build over time. This network means the volcanoes can talk to each other geologically. A surge of magma could pressurize the entire system, with pressure traveling along the tunnels. An event at one volcano could change the dynamics at another, potentially triggering or relieving eruptions. Geologists now consider the possibility of a cascade eruption, one volcano's activity triggering a chain reaction. For example, a large eruption at Hood could destabilize St. Helens, which in turn could awaken Rainier. This interconnectedness presents a new, frightening scenario for the region. The system is dynamic and interactive, not static. Emergency planners must now prepare for multi-volcano events. The science demands we rethink our approach to volcanic risk. The stakes are higher and more complex than ever before. The threats from these volcanoes are immense, and now magnified by their connection. Lava can destroy everything in its path, but the real danger is ash. Explosive eruptions send ash plumes high into the atmosphere, crippling crops, grounding plains, and threatening health. And beyond lava and ash, deadly lahars could devastate towns miles away. The risks are now greater than ever. In the face of this threat, preparation is key. Know your risks. Hazard maps show which areas are most vulnerable to lava, lahars, or ashfall. Every family should have an evacuation plan and a meeting place. Disaster kits are essential. Food, water, first aid, flashlights, radios, and N95 masks for ash protection. When evacuation orders come, act immediately. Don't wait. Keep your car's gas tank at least half full and have a plan for pets. Communities must strengthen infrastructure and rehearse evacuation plans for schools, hospitals, and businesses. Clear communication between scientists, emergency managers, and the public is vital. The USGS monitors these volcanoes for signs of unrest, earthquakes, ground swelling, gas changes. Their warnings are our best defense, but only if we're ready to listen and act. The time to prepare is now, not when the mountain roars. Individual and community readiness can save lives. The new reality demands vigilance and action from everyone. The discovery of interconnected magma tunnels is a powerful reminder the Earth is alive and ever-changing. We live on a fragile crust, above forces we're only beginning to understand. Volcanoes aren't villains, they're part of the planet's natural process. Our job is to respect and understand them, not fear them. Investing in Earth science and monitoring is critical for our safety. Every new discovery helps refine hazard maps and improve warnings. Knowledge turns catastrophe into a manageable emergency. Preparedness is a shared responsibility between scientists, agencies, and every resident. We can't stop natural disasters, but we can choose how we respond. By staying informed and ready, we build resilient communities. The story of these connected volcanoes is a lesson in humility and vigilance. We must listen to the Earth's warnings, whether from tremors or satellite data. By investing in science and preparation, we can live safely alongside these magnificent fiery giants.